Hi students, today I am going to discuss how to perform analysis of variance for single factor experiments. In Excel, you can do analysis of variance problems using any statistical software such as Minitab or IBM SPSS, but not many students have access to those software, but almost everybody has access to Excel. So how to perform ANOVA, particularly for single factor experiments using Excel, is what we are going to discuss today. So I have a simple problem here. I will read it for you and then we will try to understand the problem and then we will solve it, right? So the tensile strength of Portland cement is being studied. 4 different mixing techniques can be used economically. A completely randomized experiment was conducted and the following data were collected. So what we are studying here, what the problem statement is we are studying the tensile strength of Portland cement. So our factor is Portland cement, right? And we are studying its tensile strength. Now this factor Portland cement, we have 4 different mixing techniques that we can use. So we have 4 levels in a statistical language. We have 4 levels, or we can say our factor is mixing technique or Portland cement. So mixing technique is a factor and it has 4 levels because we have 4 different techniques that we can use. And then our output variable is the tensile strength of the formulation, the cement formulation using these mixing techniques. Now the experimenter is interested in finding out the impact of various mixing techniques on the tensile strength, right? If different mixing techniques will result into similar tensile strength for the cement, or will different mixing techniques will result in different tensile strengths for the cement. If and why do we need to know that? Because if we find out that there are differences between different mixing techniques as in the context of their impact on the tensile strength, then we want to find out which mixing technique give us the highest tensile strength, which is logical, right? Which mixing technique will give us the highest tensile strength, and we can use that in practice. So a completely randomized experiment was conducted, right? See that for mixing technique 1 here, 4 different experiments were conducted. Each time the tensile strength was for each sample the tensile strength was calculated in pound per square inch, and those results are here, the data, right? Similarly, there are 4 independent experiments were performed for mixing technique 2, and respective tensile strengths were noted, and so on and so forth. So we have this data. Now depending on this data, we want to perform the analysis. So first thing we can do is let's copy paste this data, or you can just type it, but I'm going to copy paste it because it's easy. Control C for copy, and I'm going to go to Excel and Control V. So there we are. I'm gonna do some organization here. I'm just going to increase the column size for mixing techniques. So here is my data. You can type it if you want, or you can copy paste it. Now we want to use a tool in Excel that will perform the analysis of variance. I'm not going to go into the technical details of the analysis of variance itself. You can read it from a statistical book. In this video, I'm just going to show you how to perform it. So first thing, after you have the data, you can go to the data tab on Excel, data tab, and here you will see data analysis, and in that we have analysis of variance single factor, and there are some other statistical techniques, but this is what we are analysis of variance with a single factor is what we are interested in. Now some of you may not see, when you click on the data tab, you may not see data analysis under the analysis panel. If you don't see that, then what you need to do is you need to click on file here, go to options, and you need to add in that data analysis toolpack, right? So add-ins, and here you have analysis toolpack. You can select that and then click on go button here. I already have it, so I'm not gonna do that, but you need to. So basically, once again, you click on file, you go to options, then you will have Excel options window open. There you click on add-ins, and you're looking for toolpack, analysis toolpack. Select that, click on go, and then click on OK. And then once you do that, then you come back to the data tab and you will see the data analysis toolpack, right? Now we entered the data here. The data is in rows, right? We have first mixing technique, and then we have results of 4 different experiment for that mixing technique, which is basically the tensile strengths, right, of different samples. Now the data doesn't have to be in this fashion. You can have mixing techniques as your column captions, and the tensile strength, which is in rows, can be in columns, right? So columns can become rows and rows can become columns. It doesn't matter as long as you understand how the table is laid out. Okay, so I'm going to keep it as it is. Then I'm going to click on data analysis, select the analysis of variance single factor, ANOVA single factor, click OK, and we have to define input range. So I'm going to select this is my input range, the entire table I selected. Okay, like that. We may not have to select the first row here, so maybe I fix that. I select from row number 2 onwards. So this is the data we need. We don't, with these captions are for our understanding. We don't need it in this window here. So I selected 4 rows. Okay. The data is grouped by columns or rows. As I said, mixing technique 1, all the data related to mixing technique 1, the tensile strengths of 4 different samples is in rows, is in 1 row, right? And then same for sample, second row is for mixing techniques 2, and third row for mixing technique 3. That means the data is grouped by rows. Then another thing that is important to understand is labels in first column. Do we have, if we select column, if it was in the columns, then it will say labels in first row. But since our data is grouped by rows, we selected that. Now the question is whether we have labels in the first column. So yes, the first column which says mixing technique 1, 2, 3, 4, that is actually, those are actually labels. That's not the data, that's not the tensile strengths values that we noted, right? So yes, there are labels in the first column. Then we have to define alpha value, and by default it is 0.05. It's a significance value. So you may have heard about the 95% confidence level. So how confidently, how precisely you want to calculate the answers. For example, when you run the ANOVA and you get your results, and then you want to know whether the mixing techniques have impact on tensile strengths or not. So with what confidence you can say, your answer, you can state that your answer is true with 95% confidence, right? That's the most commonly used metric. So alpha level if 5%, that means 5% error, which is very rare, is allowed, right? So again, we're not gonna make any changes here. Then where do you want to put the outputs? You can put it in the new worksheet, or you can define some range in the existing worksheet. So I select new worksheet here, and that's about it, which is very simple. So click OK, and here you have the answers. So there is summary here, summary table. But what, so for example, summary table says group 1, 2, 3, 4, which is the mixing technique. How many experiments were conducted, how many samples were collected, so 4. The summation of the tensile strength values, the average of the tensile strength values for the 4 samples for group 1, and the variance. So some descriptive statistics is given, but what we are more interested is in this second table, which is the ANOVA table. So in this table you will see that the source of variation, meaning if there was no variation, for example, the mixing technique has no impact on the tensile strength, then we wouldn't be seeing different numbers, right? I mean, the variation in the values of tensile strength are because of two things. We suspect, right? One suspicion is different mixing techniques may have different impact, and that may be causing different tensile strength values, which is a good thing, because if that is the case, then we will select the best mixing technique that gives us the best tensile strength. And then even though mixing techniques may not have any impact on the tensile strength, they may all be same, but there will be experimental noise, standard noise, right? Every time you conduct an experiment, you're gonna get different answer, just because there are a lot of experimental noise that cannot be accommodated. You cannot have a completely homogeneous condition during each experiment, right? Maybe operator is different, person performing the experiment is different, maybe the atmospheric conditions are different. So even though mixing techniques may not have any impact on tensile strength, you may still get that, you're not gonna get the same answer every single time you conduct the experiment. It's impossible, right? So that noise will give us the different noise, or that variance will give us different values here. So in ANOVA table, we are talking about source of variation. So source of variation between groups is what we are looking for, right? Between different mixing techniques. That is important because that's what our study is about. And a source of variation within group, which is just a noise, experimental noise, we are not interested in that, right? So what can you read from this table? So there is a sum square values, degrees of freedom, mean square values. Once again, I'm not going to go into the details of each of these. I'm just going to go to the final conclusion. So what the ANOVA table calculates for you is F value between groups, F value, value of F statistics, and associated P value. Now, quickly I'm going to say that if you are, and even before I say that, I'm going to go back to the problem statement here. Now, before we do any statistical analysis in Excel or any other software, we have to rewrite this problem statement in the form of hypothesis testing. In hypothesis testing, there are generally two hypotheses we make, null hypothesis and alternative hypothesis. So null hypothesis, we're gonna say that different mixing techniques, and we are only, our observations or our hypothesis only related to these 4 mixing techniques. So to be precise, our null hypothesis can be the 4 different mixing techniques do not have any varying impact on tensile strength. So if I take average value of these 4 readings, if I take average value of these 4 readings, same thing for group 3 and group 4, and when I take these averages, they should all be same, because mixing techniques do not have varying impact on tensile strength, right? So in null hypothesis can be, in statistical language we say mu1, that means average of the first group is equal to mu2, average of the second group, average of these values, right, tensile strength values, is equal to mu3 is equal to mu4. That means there are no differences between different mixing techniques. So the null hypothesis can will be mu1 is equal to mu2 is equal to mu3 is equal to mu4. 4 averages are same, no differences. And the alternative hypothesis is at least one of them, they all 4 of them don't have to be different from each other, but at least one of the mixing technique have different impact as far as tensile strength values are concerned as compared to the remaining ones, right? If even one is different, then a null hypothesis cannot be true, it should be rejected. An alternative hypothesis is true, right? So those 2 hypotheses, and then we perform the statistical analysis, and now we look back at our hypothesis and say which hypothesis is true. The null hypothesis, which says no differences, or alternative hypothesis that says at least one of them is different. So that f value and p value will give us that answer. So, and then there is another value, f critical value. If you see the f distribution curve, again I'm not going to go into that, but here any value of f that is above the f critical on the f distribution curve, right? Any value of f that is higher than f critical, like in this case, our f value from the data is 12 and f critical value is 3.49. So f value for our data is higher than f critical value. That means null hypothesis should be rejected. And when we say rejected, that means the null hypothesis says that there are no differences between mixing techniques. That hypothesis we are rejecting. That means we are saying because f value is higher than f critical value, there are differences between mixing techniques. At least one of the mixing technique is different than the others. There may be more, there are differences. That's all we can say right now, right? There are differences between mixing techniques. So that's one way to look at it. Another way to look at it is p-value. Our alpha value was 0.05, 5% alpha value we used, right? So if p-value is less than alpha, less than 0.05, if p-value is less than 0.05, in this case it is 0.00, or it's almost 0, but as long as p-value is less than 0.05, we should reject the null hypothesis. And once again we can say the alternative hypothesis is true, which says that there are differences between different mixing techniques or their impact on the tensile strength of the cement. So that's how we perform the analysis of variance. So we have a problem statement, then we form our hypothesis, null hypothesis and alternative hypothesis. Then we can perform the analysis of variance in Excel using the data analysis tool pack. And finally, once we get the ANOVA table, we can make conclusions based on the f value or p value. So I hope you understand, and I am going to stop here. So thank you.